For question number 3, we have the velocity of a particle that is moving along the x-axis varies in time according to this expression here. Okay, so they're given us an expression. So we have to find the average acceleration in the time interval between 0 to 2 seconds, and we know that acceleration is the rate of change of velocity. So delta V over delta t. So the time is delta t equal to 2 minus 0, so 2 seconds. Okay, delta V pula, we need to calculate at V equal to 2 seconds minus, that is not V, velocity. Okay, velocity at 2 seconds minus velocity at 0 seconds. Okay, so this is gonna be 40 minus 5. This is 2 seconds. So square minus 40 minus 5, 0. Okay, so dapat this is 40 minus 20, so 20 minus 40, so that is negative 20 meter per seconds. So your average acceleration is equal to negative 20 divided by 2, which gives us negative 10 meter per second square. Okay, so that is how you find the average acceleration. Next, we have to determine the acceleration at t equal to 2 seconds. Okay, so again, this is acceleration, and we know that acceleration is the rate of change of velocity. So basically, we can actually differentiate the equation with respect to time. Okay, so this one, it will be 40 is gonna be 0 sebab dia tidak ada constant t di situ, dia tidak ada value t di situ, huruf t di situ. So kita akan bila kita derive dia, kita akan ignore dia. So sekarang ni kita boleh consider 5t square sahaja. So if we derive something, it will the power will be going down, and then the power will be minus 1, will minus 1 lah. Okay, so dia jadi negative 2 5t. So dapat negative 10t. So dari sini kita boleh substitute t equal to 2 seconds. So kita akan dapat negative 20 meter per second square. So this is instantaneous acceleration lah. Sebab dia mention t dia 1 saja. So macam at that instant, acceleration dia adalah negative 20 meter per second square at t equal to 2 seconds. Alright? Okay, lepas tu kita perlu cari, okay, so next is question number 4. For question number 4, this is on projectile motion. So a stone is thrown from the top of a building. So if we were to draw a building, something like that lah. Okay, so the stone is thrown upwards. Kena buang oleh orang lah, okay. Okay, macam ni je. Oh my god. Okay, so sekarang ni, this is our initial velocity. Okay, so this initial velocity is only present in the y component. So I'm gonna label it as uy equal to 20 meter per second. Sebab soalan tulis sana dia ada initial velocity of 20 meter per second. So the motion of this this stone is actually gonna be looking like this. Okay, and then dia akan go straight down to the ground. Okay, boleh lah macam tu. Alright, so from here, we know that the y component of the velocity is equal to 0. Okay, sebab sekarang ni kita ada y component saja. Dia tidak bergerak di x component. Meaning, the final velocity in the x component should also be equal to 0. Sebab ux is equal to vx. Alright? Okay, so enough with that. Next, we have to see what? Okay, so the building is 50 meter high. So we label it as 50 meter lah. Okay, 50 meter. So we have to determine the time at which the stone reached its maximum height. So the maximum height, at maximum height, what we need to remember is the velocity, final velocity at the y component should equal to 0. Okay? So dari sini kita boleh tengoklah formula dia. So this is a formula sheet that I've written for my students. Basically the black color ni semua ada di dalam kamu punya formula sheet. It's given, so you don't really have to memorize it. You just have to know how to apply it during exam. Okay, so these are the 4 equations that are available. So depends on what is asked and what is available. Kamu tengoklah betul-betul mana satu yang boleh guna. So sekarang questions minta time saja, and at maximum height. So we do not have the displacement ataupun the maximum height, the value of the maximum height. So we can actually use equation number 1 saja. Alright, so that's gonna be Vy equal to Uy minus Gt. Okay, so I'll label this as T to reach maximum height. Okay, so if we rearrange this and we know that Vy is equal to 0, we will get an equation of Uy minus Uy over G. Sorry. So dari sini barulah kamu substitute the value. So Uy is 20 over 9.81, which gives you, if I'm not mistaken, 2.04 seconds. Yeah, it's correct. So 2.04 seconds is the time to reach the maximum height. Okay? Alright, next question B pula. Dia minta the maximum height of the stone above the rooftop. Okay, so dia minta above the rooftop. Sampai sini berapa dia punya nilai maximum height. So since we already have the time, you can actually use the time untuk cari the value of maximum height. But if you are not confident about your answer here, you can actually use Vy lagi. Okay, so Vy equal to 0 ni kita boleh guna lagi untuk the equation Vy Uy square minus 2G Sy, where Sy is our maximum height. Okay, so kalau kamu guna equation yang ini, kamu confirm boleh betul, dapat betul lah. Tapi kalau kamu guna yang time, if your time is wrong, there's gonna be boleh lose mark lah kiranya, tidak dapat full mark. Okay, but usually they kind of accept apa yang salah di sini and then kasih betul di sini sebab solution kamu betul, just the final answer saja salah. Begitulah. Okay, alright, so now Sy is equal to, again this one equal to 0, so Sy is equal to Uy square over 2G. Okay, so this is 29.81, and then this is 20 square. So 20 square over 29.81 is equal to 20.39 meter. Okay, so that is the maximum height above the rooftop. Okay, so it's not the whole displacement in y component, it is just the maximum height above the rooftop. Okay, right. Next, the time at which the stone returns to the level of the thrower. Okay, untuk this case, you have to let this part here to be equal to 0. What yang equal to 0? Your h ataupun your sy equal to 0. Okay, so basically this is the reference line. Okay, ini adalah reference line. So reference line helps you in determining whether the displacement is positive atau negative. So anything below the reference line should be negative, anything above is positive. So that's why sy kamu di sini ataupun your, sorry, this should be maximum height. That's why your maximum height is positive sebab it is above the reference line. Okay, tapi sekarang ni dia minta ngam di reference line. Dia minta the time. Okay, so maksudnya kita boleh guna the equation yang ada displacement and time. So di sini kita boleh letak sy is equal to h, which is equal to 0. Alright, so we can use the equation sy uyt minus half gt square to find the time. Okay, so the time ni kamu boleh label as anything lah, tapi for me I'm just gonna label it as t supaya senang malas pula. Alright, so this one's gonna be equal to 0, and then you will get a quadratic equation here. So I'm gonna pindah supaya our t square is gonna be positive. This is 20, t equal to 0. Okay, so just put it, substitute this into your calculator. So we have half 9.81 and then negative 20, c is 0. Okay, so kamu akan dapat t1 equal to 4.08 seconds, and then the next one is 0 seconds. Okay, so basically the one yang paling logic is the one yang ada value lah, sebab after dia cakap sekarang ni returns to the level of the thrower. So after dia buang sini, berapa lama masa dia sampai balik pergi this level. Kalau t equal to 0 tu tiada pergerakan langsung lah, itu initial, itu sebelum dia buang lagi. So kamu perlu declare, letak sini def t is equal to 4.08 seconds. Okay, jangan lupa tulis tu, sebab kalau kamu kasih letak di sini dia terus kamu letak tick dia tepi, sometimes it is unacceptable. Okay, so just biasakan diri untuk buat yang macam ni lah. Okay, alright, next one, lastly, the velocity and position of the stone at t equal to 5 seconds. Okay, so untuk this one, velocity is a vector, remember. So untuk this question saja yang vx dia equal to 0, vy pula it is equal to uy minus gt, where uy is 20 minus 9.81. So t yang mana satu kita mau guna is the t, the t yang kita boleh guna is the t to reach, oh wait, let me just see. What did I use? I forgot. Let me double check. Oh, astaga, why am I confused? It mentioned, sorry everybody, patutlah. So the t here is t equal to 5 seconds. So vx is still equal to 0 because vx is equal to the initial velocity, so it's equal to 0. T is equal to 5. No wonder I'm confused. Yeah. Okay, so you will get Let me just put this in the calculator. You will get negative 29.05 meter per second. Okay, so the velocity actually is just equal to negative 29.05 meter per second. The direction is the sign, which is downwards lah. So you can either write it down as downwards ataupun leave it at negative je pun tidak masalah, because negative is telling us the direction. Next, the position at 5 seconds. So position is displacement, and displacement is also a vector. So we have the x and y component lah. Since sx is equal to uxt, we know it will also be equal to 0 meter. Okay. Next, we have to find sy. So this is uyt minus half gt square. So this is 25 half 9.81 20 square. Alright, so kira dia minus half 9.81 20 square. Okay, so kamu akan dapat negative 1862. What did my students give me last? 22.63. What did I do wrong? Oh, 20. Patla. 5 square. Sorry, everybody. I don't know what's happening to me. Okay, so it's negative 22.63 meter lah. So again, you can just let s equal to 20 negative 22.63 meter, ataupun negative tu kamu buang, kamu letak sini downwards. Okay, but if you want to write both negative and downwards, it's actually not really a problem. Okay, all right, so that is on question 3 and question 4.